Hello students, welcome to video lecture on multiple choice questions on complex numbers. In earlier videos on complex numbers, I have discussed about complex numbers, algebra of complex numbers, polar form and exponential form of complex numbers, powers of complex numbers, roots of complex numbers, as well as logarithm of complex numbers. Now in this video lecture, I will discuss some multiple choice questions on complex numbers. These multiple choice questions are useful for different competitive examinations in physics like IIT JAM Physics, GATE Physics, NET and SET Physics, as well as other entrance examinations in physics. So let us start explanation of multiple choice questions on complex numbers. So I will take first question. This question was asked in IIT JAM examination. The value of square root of I plus square root of minus I, where I, that is called iota, is equal to root of minus 1 each. Now first is 0, second one is 1 upon root 2, third one is root 2, fourth one is root of minus 2. So here we have root of I plus root of minus I, and we have to find its value. So suppose we divide this by root of I minus root of minus I and multiply by the same, that is root of I minus root of minus I. So here this one will be equal to, I will get root of I minus root of minus I in the denominator. Now at the numerator, root of I into root of I, that is I. Now root of I into root of minus I, that is minus root I into minus root minus I. Then root of minus I into root I. So plus root of minus I into root I and minus root of minus I into root of minus I. Now here we can write this as I minus, now root of I into root of minus I, we can take root of minus I into I, that is I square, plus root of minus I square minus root of minus I into minus I, that is I square, divided by root of I minus root of minus I. Now this one will be equal to I minus root of now. Now we know I is root of minus 1. So I square is minus 1. So minus I square is equal to 1. So we'll get here root of 1 plus root of 1 minus I square, that is I. Root of I square is I. So we get here root of I minus root of minus I. So this is equal to I minus 1 plus 1 minus I divided by root of I minus root of minus I. So now I will cancel with this I, 1 will cancel with this. So this comes out to be 0. So this first one is correct. So first one is correct. Now we'll go to second one. The phase of complex number 1 plus I in bracket multiplied by I in the polar representation is A pi by 4, B pi by 2, C 3 pi by 4, D 5 pi by 4. Now we know if Z1 it is first complex number and Z2 it is second complex number. Then what happens? If we multiply them, you will get argument of Z1, Z2, it is equal to argument of Z1 plus argument of Z2. Now here we have first complex number, that is Z1 is equal to 1 plus I and Z2 is equal to I. Now first we will see here 1 plus I. So here x is equal to 0, x is equal to 1, y is equal to 1. So r is square root of x square plus y square. I will call this as x1 y1. So r1 x1 y1. So r1 is equal to what? Root of 1 square plus 1 square, that is root of 2, and theta is equal to tan inverse y by x. So it is theta 1. So theta 1 is equal to tan inverse 1 by 1. So theta 1 is equal to pi by 4. Pi by 4. Now if we take here second complex number, you can write this as Z2 is equal to 0 plus I. So x2 is equal to 0, y2 is equal to 1. So r2 is equal to root of 0 plus 1, that is 1. And theta 2 is equal to tan inverse here y by x. So it is tan inverse infinity. 1 upon 0 is infinity. So theta 2 is equal to pi by 2. Now here 1 plus I into I, that is Z1 into Z2. So argument of Z1 into Z2 is argument of Z1 plus argument of Z2. So it is pi by 4 plus pi by 2. So we get here 4 and pi plus 2 pi. So we will get here 3 pi by 4. So here this third one is correct. Third one is correct. And that is also called phase of the complex number. Now we will go to third one. Which of the following point represents complex number z is equal to 1 upon 1 minus I? So here complex planes are given and this point or this point or this point or this point, that represents, these points represent representation of complex number on z plane. So we have to find x and y for the given complex number. Now what is given complex number? Z is equal to 1 upon 1 minus I. So we can write Z is equal to 1 upon 1 minus I multiplied by 1 plus I upon 1 plus I. So we have multiplied and divided by complex conjugate of 1 minus I. So we get here 1 plus I divided by, now Z into Z bar, that is modulus of Z. Modulus of Z square. So we'll get here 1 square plus 1 square, that is 2. So we'll get 1 plus I upon 2. So Z is equal to 1/2 plus I by 2. So Z is equal to 0.5 plus 0.5 I. So here x is equal to 0.5, y is equal to 0.5. So if we see here, both are positive. Out of 4 1, in first one we have 0.5, this one. So this first one is correct. Here 0.5 minus 0.5, so this is not correct. Here 1 minus 1 is not correct. 1 is also not correct. So this question was also asked in IIT JAM examination. Now next one. Let Z be the complex number such that Z is equal to 3 plus I minus modulus of Z. Then Z is equal to A 5 by 3, B 5 by 4, C root of 41 by 3, D 3 by 5. Now we take here Z is equal to X plus IY. Okay, Z is equal to X plus IY. Now modulus of Z is equal to root of X square plus Y square. We know this. Now Z is equal to given, that is 3 plus I minus modulus of Z. So we can write this as Z plus modulus of Z is equal to 3 plus I. Now Z is X plus IY plus square root of X square plus Y square, and this is equal to 3 plus I. So we will get here X plus square root of X square plus Y square. I will take this in first bracket plus IY. So 3 plus I. Now see, on left hand side we have complex number, on right hand side we have complex number. So this is real part and this is imaginary part. This one is real part and 1. We can take here 1. 1 is imaginary part. So if we compare, we get y is equal to 1 and x plus square root of x square plus y square is equal to 3. So we got this. Now, since y is equal to 1, this second equation, this one, we can write x plus x square plus 1 is equal to 0. Sorry, equal to 3 because y is equal to 1. So we can write this as root of x square plus 1 is equal to 3 minus x. So square on both sides. So if we square on both sides, we'll get x square plus 1 is equal to 3 minus x bracket square. This gives you x square plus 1 is equal to 9 minus 6x plus x square. Now this x square will go with this one. So we'll get 6x. So I can take 6x here, 1 here is equal to x. So x is equal to 8 by 6. Eight by 6. 8 by 6. So we got x is equal to 8 by 6. Now modulus of z is equal to root of x square plus y square. So this is equal to root of 8 by 6 square plus 1. Y is 1. So we will get root of 64 by 36 plus 1. So we will get this as root of 64 plus 36 by 36. So we will get root of 100 by 36. So it is 25 by 9. That is modulus of z. So we will get modulus of z is equal to, this one will be equal to 5 by 3. Square root of that is 5 by 3. So here out of these 4, this first one is correct. 5 by 3. 5 by 3 is correct. Now we'll go to next one. What is argument of 1 plus 2i upon 1 minus 3i? So here we can take this as so argument pi by 2, 3 pi by 2, 3 pi by 4, pi by 6. So here we have z is equal to 1 plus 2i divided by 1 minus 3i. Now let us multiply it by complex conjugate of denominator. So here now you will get at the denominator we get 1 plus 9, 1 square plus 3 square, and now 1 into 1, that is 1, plus 1 into 2i, that is 2i, plus 2i into 3i, so plus 3i into what, minus plus 6i square. So you will get here divide by 10. Now 1 plus 5i minus 6, because I square is minus 1. So you will get here minus 5 plus 5i divided by 10. So we will get this as minus 1 half plus 1 half I. So here x is equal to 1 minus 1 half, y is equal to 1 half. So you will get r is equal to square root of x square plus y square. So it is root of 1 by 4 plus 1 by 4. So it is root of 2 by 4. It comes out to be 1 upon root 2. And we know theta is equal to cos of x by r, or theta is equal to sine of y by r. So I can write here x is cos inverse, minus 1 half divided by 1 upon root 2. So this comes out to be cos minus 1 upon root 2. Minus 1 upon root 2. Now cos minus 1 upon root 2, it is 3 pi by 4. 3 pi by 4. So here out of these 4 alternatives, this third one is correct. 3 pi by 4. Now let us go to next one. Polar form of the complex number minus 3 plus 3i each. Now a is equal to 3 e raised to I 3 pi by 4. B is equal to 3 root 2 e raised to I 3 pi by 4. C is equal to 3 root 2 e raised to I pi by 4, and D is equal to 3 e raised to I pi by 4. Now here if we have z is equal to x plus iy complex number, you can write this as r is equal to z is equal to r in bracket cos theta plus I sin theta. This is polar form, where r is equal to root of x square plus y square, and x is equal to r cos theta, y is equal to r sin theta. So cos theta is equal to x by r. So theta is equal to cos inverse x by r, or theta is equal to cos inverse, sin inverse y by r, or you can write theta is equal to tan inverse y by x also. Now here z is equal to minus 3 plus 3i. So x is equal to minus 3, y is equal to 3. So r is equal to x square. Minus 3 square is 9 plus 9. So it is root of 2 into 9. So you will get here 3 root 2. That is r. Now theta is equal to cos inverse x is minus 3, r is 3 root 2. So we get here cos inverse minus 1 upon root 2, and this is equal to 3 pi by 4. Now exponential form of complex number is z is equal to r e raised to I theta. So r is 3 root 2 e raised to I into 3 pi by 4. So this is exponential form. So here this second one is correct. This second one is correct. Now next one, log x plus iy can be expressed as. So we have given 4 alternatives. We have to find correct alternative. Now we can take here z is equal to x plus iy. So here we have log z, log to the base e. Now we know we can write this z as r e raised to I theta. Z is equal to r e raised to I theta. So log z, log to the base e, is equal to log r plus I theta. Now here r is what? Root of x square plus y square, and theta is what? Tan inverse y by x. So I can write log e, log to the base e, log to the base e, x plus iy is equal to log to the base e. Now r is root of x square plus y square plus I into argument of complex number, that is tan inverse y by x. So this is the representation. So out of these 4, log x square plus y square, this is not correct. Log e x square plus y square, this is not correct. Log e in bracket root of x square plus y square minus, so this is also not correct. Log e root of x square plus y square plus I tan inverse y by x. So this one is correct. This one is correct. Now next one, the real part of log to the base e 3 plus 4i is a log 2, b log 3, c log 4, d log 5. Now here we have seen log z means here log to the base e z is equal to log to the base e r plus I theta, and this one is real part. So what is r? R is root of x square plus y square. Now in 3 plus 4i, x is 3, so 3 square is 9 plus 4 square is 16. So you will get root of 25, that is 5. So real part is what? Log 5. So out of 4 alternatives, this last one is correct. This last one is correct. Now next one. What is the value of n if log n is equal to 0.692 plus pi I? Now we have already seen if we have log z, it is equal to log z means modulus of z log r plus I theta. If z is complex number, then z is equal to what? R e raised to I theta. Now if we compare here, suppose z is equal to suppose n. So n is equal to r e raised to I theta. Now log r is given, that is 0.692. So r is approximately equal to 2 because log 2 is 0.693. So it is 2. So here n is equal to 2 e raised to I pi means 2 cos pi plus I sin pi. This is polar form. So n is equal to 2 cos pi is minus 1 plus I 0. So n is equal to minus 2. N is equal to minus 2. So out of 4 alternatives, A is 2. So this is not correct. B is minus 2. This is correct. This is not correct. This is not correct. Now we'll see next one. What is the multiplicative inverse of 2 minus 3i? And we have 4 alternatives. So if Z1 is complex number, Z1 is complex number, and here if we take Z1 into Z2 is equal to suppose 1, then Z2 is multiplicative inverse. Multiplicative inverse. So I can write Z2 is equal to 1 upon Z1. So here 1 upon 2 minus 3i. So we can find Z2, that is multiplicative inverse, that is 1 upon 2 minus 3i. Let us multiply by 2 plus 3i and divide by 2 plus 3i. That is complex conjugate of this denominator. So we get here 2 plus 3i. Now this is z into z bar. That is z bar square. That is 2 square modulus of z square. 2 square plus 3 square. So 2 plus 3i upon 4 plus 9. So you will get 2 plus 3i upon 13. So it is 2 by 13 plus 3 by 13 I. So here 2 by 13 plus 3 by 13, first one, this is correct. This one here we have minus sign, so this is incorrect. Here 3 and 2, so this is incorrect. 4 and 9, so this is incorrect. Now next one, if z is equal to cos theta plus I sin theta, then z raised to n plus 1 upon z raised to n is equal to. Now A n cos theta, B n cos n theta, C n cos n theta, and D 2 cos theta sin theta. So we know Z is equal to cos theta plus I sin theta. So Z raised to n is equal to cos theta plus I sin theta raised to n. And if we use de Moivre's theorem, we can write this as cos n theta plus I sin n theta. And 1 upon z raised to n, we can write z raised to minus n. So it is cos theta plus I sin theta raised to minus n. So we can write this as cos minus n theta plus I sin minus n theta. But cos minus n theta, that is cos n theta. And sin minus n theta, it is minus sin n theta. So I will write I sin n theta. So z raised to n plus 1 by z raised to n, it is equal to cos n theta plus I sin n theta plus cos n theta minus I times sin n theta. So now this one will cancel with this. So we'll get 2 times cos n theta. So here this third one is correct. 2 times cos n theta. Now let us go to next one. What will be the value of 1 plus I raised to 15? 1 plus I raised to 15. So first we will convert that complex number 1 plus I into polar form. So here z is equal to 1 plus I. So x is equal to 0. X is equal to 1, y is equal to 1. So r, that is square root of x square plus y square. And this is equal to square root of 1 plus 1, that is square root of 2. And theta is equal to tan inverse y by x. So it is tan inverse 1 by 1, that is 1. So it is pi by 4. And we know z is equal to r in bracket cos theta plus I sin theta. So here z is equal to, we get here r means root 2 in bracket cos pi by 4 plus I sin pi by 4. This is polar form of the complex number. Then we have to take 15th power. So z raised to 15, that is 2 raised to 15 cos pi by 4 plus I sin pi by 4 raised to 15. So here z raised to 15 is equal to, now I can write this as root 2 raised to 14 into root 2, this first term. And here cos 15 pi by 4 using de Moivre's theorem plus I sin 15 pi by 4. This is using de Moivre's theorem. So now z raised to 15 will be equal to, now this is 2 raised to 7 square root 2 raised to 14 into root 2. Now here we can write cos. Now this one is, we can write 4 pi minus pi by 4 plus I sin 4 pi minus pi by 4. So 15 pi by 4 we can write cos 4 pi minus pi by 4. Means 4 pi minus pi by 4, it is 15 pi by 4. 4 into 4, that is 16 pi minus pi by 4, that is 15 pi by 4. Now if we see here, if we take cos 4 pi minus pi by 4, this is equal to cos 4 pi into cos pi by 4 plus sin 4 pi into sine pi by 4. Now cos pi by 4 is 1. Sine pi by 4 is 0. So we get this as cos pi by 4, that is 1 upon root 2. That is 1 upon root 2. Similarly, we can write sine 4 pi minus pi by 4. Now if we solve this, we will get this is sine 4 pi into cos pi by 4 minus cos 4 pi into sine pi by 4. Now first term is 0 because sine 4 pi is 0. Here cos 4 pi is 1. So we will get minus sine pi by 4. So it is minus 1 upon 2 raised to 15 is equal to, now 2 raised to 7, it comes out to be 128 into root 2 in bracket. Now cos 15 pi by 4 we got 1 upon root 2 minus I 1 upon root 2, that is sine 15 pi by 4. So we get here root 2 will get cancelled. So we'll get 120 minus 128 minus 128i. So this is 15th power. So 128. So the second one is correct. Second one is correct. Now we'll go to next one. If z is equal, if modulus of z plus 2 is equal to 3 times modulus of z minus 1, where z is equal to x plus iy, represents a circle having radius dash dash dash, a 1 half, b 3 by 2, c 5 by 4, d 7 by 2. So what happens here? If we plot this equation, modulus of z plus 2 is equal to 3 times modulus of z minus 2 on complex plane, you will get a circle with some center and radius. So we have to find that radius. So here z plus 2, that is x plus iy plus 2, and modulus of that is equal to 3 times modulus of x plus iy minus 2. So we can write like this. Now here you can write this as x plus 2 plus iy modulus is equal to 3 x minus 2 plus iy modulus of this. So here modulus of z, it is root of x square plus y square. So you will get here square root of x plus 2 square plus y square, because here real part is x plus 2, is equal to 3 into square root of x minus 2 square plus y square. Now squaring on both sides, we get here x plus 2 square plus y square is equal to 9 in bracket x minus 2 square plus y square. So we'll get here x square plus 4x plus 4, that is square of x plus 2 plus y square is equal to 9 in bracket x square minus 4x plus 4, that is x minus 2 bracket square plus y square. So this equation gives x square plus 4x plus 4 plus y square is equal to 9x square minus 36x plus 36 plus y square. Now if we bring this on this side, so 9x square minus x square will get 8x square minus 36x minus 4x will get minus 40x plus 36 minus 4 will get 32. Here we have 9y square plus 9y square minus y square will get 8y square. This is equal to 0. So divide throughout by x square will get 8, divide throughout by 8 we get x square minus 5x plus 4 plus y square is equal to 0. So we got this equation. And what is this equation? So here x square minus 5x plus 4y, I will make slight adjustment. So x square minus 5x, suppose we add 25 by 4 and subtract 25 by 4, minus 25 by 4 plus 4 plus y square. So we will get here x square minus 5x plus 25 by 4 plus y square is equal to 25 by 4 minus 4. So these two, here it is equal to 0. So these are taken here. So we get this. So we get here x square minus 5x plus 25 by 4 plus y square is equal to 25 minus 16 and whole divided by 4. So here we have 9 by 4. And here if we take these two terms, we can write this as x minus 5 by 2 square plus y square. So I can write this as x minus a square plus y minus b square plus r square, where a is equal to 5 by 2, b is equal to 0 and r is equal to 3 by 2. So here this equation represents circle with center 5 by 2, 0 and radius 3 by 2. So radius of the circle is 3 by 2. So B is correct. So 3 by 2 is correct. Now we'll go to next question. Complex number z is equal to x plus iy, which satisfies the equation modulus of z minus 5i upon z plus 5i is equal to 1. Lie on. So here first one is the x-axis, second one is the straight line y equal to pi, third is a circle passing through the origin, and fourth one is none of the above. Now here we will solve this. Now z minus 5i upon z plus 5i is equal to 1. So I can write this as z minus 5i modulus divided by modulus of z plus 5i, and this is equal to 1 because modulus of z1 upon z2 is equal to modulus of z1 upon modulus of z2. So here we can write modulus of z minus 5i is equal to modulus of modulus of z plus 5i. Now z is equal to x plus iy. So we get here x plus iy minus 5i is equal to x plus iy plus 5i. So we get here x plus I y minus 5 modulus of this will be equal to x plus I y plus 5 modulus of this. And we know modulus of z, that is square root of x square plus y square. Square root of real square root of square of real part plus square of imaginary part. Here real part is x, imaginary part is y minus 1. So this is equal to x square plus y minus 5 square, and this is equal to square root of x square plus y plus 5 square. So we get this. So here now squaring on both sides. So we'll get x square plus y minus 5 square is equal to x square plus y plus 5 square. So we get here y minus 5 square is equal to y plus 5 square. So here y square minus 10y plus 25 is equal to y square plus 10y plus 25. Now if we solve this, y square will cancel with this. So we'll get 20y is equal to 0. So we'll get y is equal to 0 for this. Y is equal to 0 means this lies on x-axis, because y is always 0. So this first one is correct. First one is correct. The complex number z is equal to x plus iy, we satisfied the condition. Modulus of I plus z upon I minus z is equal to 1 lies on circle x square plus y square is equal to 1, the x-axis, the y-axis, the line x plus y is equal to 1. We have already said. So we can write modulus of I plus z upon modulus of I minus z is equal to 1. So here I plus x plus iy, modulus of this I minus x minus iy, modulus of this is equal to 1. So we get here x plus I y plus 1 modulus will be equal to x minus I y minus 1. So here we'll get root of x square plus y plus 1 square is equal to root of x square plus y minus 1 square. So we get here x square plus y plus 1 square is equal to x square plus y minus 1 square. So x square will get cancelled. Y square plus 2y plus 1 is equal to y square minus 2y plus 1. So y square will get cancelled, and you will get 4y is equal to 0, means y is equal to 0. So this lies on x-axis. We have already seen such a type of example earlier. Now next one. If 1 plus I upon 1 minus I raised to m is equal to 1, then m is equal to 2 raised to n plus 1, m is equal to 4n, m is equal to 2n, m is equal to 4n plus 1, where n is positive integer. Now we will take here 1 plus I upon 1 minus I and multiply it by complex conjugate of the denominator. So we get here 1 plus 1, that is 2. And here 1 plus 1 into 1, that is 1, plus 1 into I, plus I into 1, I into I, that is I square, so plus I square. So we'll get this as 2I upon 2, so this is I. So here I, we got this one I, and then I raised to m is equal to 1. We know I square is minus 1, I raised to 4 is 1, I raised to 6 is minus 1, I raised to 8 is 1, I raised to 10 is minus 1, I raised to 12 is 1, like this. So in general, if m is equal to 4 times n, where n is equal to 0, 1, 2, 3, 1, I raised to 4n will be equal to 1 if n is equal to 0, 1, 2, 3, and so on. So this second one is correct. Second one is correct. Now we'll go to next one. We'll go to next one. If z is equal to in bracket root of 3 by 2 plus 1 half I bracket raised to 5 plus root of in bracket root of 3 by 2 minus 1 half I bracket raised to 5, then first one real part of z is 0, second imaginary part of z is 0, third real part is 0, imaginary part is greater than 0, d real part is greater than 0, imaginary part is less than 0. Now we'll solve this. So we'll take here z raised to 5 plus z bar raised to 5 is equal to how much? So let us take z is equal to root 3 by 2 plus 1 half I. So here this is equal to, now x is equal to root 3 by 2, y is equal to 1 half. So you can find r. R is equal to root 3 by 2 square, that is 3 by 4 plus y square, that is 1 by 4. So we'll get here 1. This is 1. 3 by 4 plus 1 by 4 and square root of that. And theta is equal to tan inverse y by x. So it is tan inverse 1 half by root 3 by 2. So it is tan inverse 1 upon root 3. So this is equal to pi by 6. So z is equal to r e raised to I theta. So it is 1 into e raised to I pi by 6. And z bar, it is equal to e raised to minus I pi by 6. That is next one. So z raised to 15, z raised to 5, it is e raised to I 5 pi by 6, and z bar raised to 5 is equal to e raised to minus I 5 pi by 6. Now if we take this z raised to 5, it is equal to cos 5 pi by 6 plus I sin 5 pi by 6. And this one is what? Z bar raised to 5 is equal to cos 5 pi by 6 minus I sin 5 pi by 6. Now first we will find what is cos pi by 6. Now cos pi by 6 I can write cos 5 pi by 6. We can write here cos pi minus pi by 6. So this is equal to cos pi into cos pi by 6 plus sin pi into sin pi by 6. Now this comes out to be cos pi is minus 1, cos pi by 6 is that is root 3 by 2 plus 0. So it is minus root 3 by 2. And sine 5 pi by 6 is equal to sine pi minus pi by 6, that is sine pi cos pi by 6 minus cos pi sine pi by 6. Now sine pi is 0, so we will get here minus into minus cos pi, that is plus 1, into sine pi by 6, that is 1 half. So it is 1 half. So z raised to 5 is equal to this plus this. So it is minus root 3 by 2 plus I into 1 half. And z bar raised to 5, that is equal to minus root 3 by 2 minus I into 1 half here. So what is z bar, z raised to 5 plus z bar raised to 5 is equal to minus root 3 by 2 plus I 1 half, I into 1 half, minus root 3 by 2 minus I into 1 half. So this gives you minus root 3 plus 0 I. So if we see here, real part is not 0, real part is less than 0, while imaginary part is 0. So out of this, real part is not 0, so this is incorrect. Imaginary part is 0, okay, but here real part is 0, imaginary part is greater than 0, this is incorrect. Real part greater than 0, imaginary part less than 0, this is incorrect. So imaginary part is 0, this is correct. Now we'll go to next one. If 1 in bracket 1 plus I raised to 8 plus 1 minus in bracket 1 minus I raised to 8 comma, then real part is 0, imaginary part is 32, real part is 32, imaginary part is 0, real part is minus 16, imaginary part is 16, real part is 16, imaginary part is less than 0. So here we will take z is equal to 1 plus I and z bar is equal to 1 minus I. Now here x is equal to 1, y is equal to 1. So we get r is equal to root of 2, that is x square plus y square, root of x square plus y square. And theta is equal to tan inverse 1 by 1. So we get tan inverse, that is pi by 4. So 1 plus I, that is z, r e raised to I theta. So z is equal to, now we'll get r is root 2 e raised to I pi by 4. So what is z bar? Z bar we will get root 2 e raised to minus I pi by 4. So z raised to 8, that is root 2 raised to 8 e raised to I pi by 4 raised to 8. And z bar raised to 8 is equal to root 2 raised to 8 e raised to minus I pi by 4 raised to 8. So we get z raised to 8 is equal to root 2 raised to 8, that is 2 raised to 4 e raised to I into 2 pi. So here we will get 2 raised to 4 cos 2 pi plus I sin 2 pi. Now cos 2 pi is 1, sin 2 pi is 0. This is 1. So we will get 2 raised to 4, that is 16. So z raised to 8 is 16. Now z bar raised to 8, that is again 2 raised to 4 e raised to minus I 2 pi. So we'll get 16 in bracket cos pi minus cos 2 pi minus I sin 2 pi. So this is equal to 16 because cos 2 pi is 0, 1 sin 2 pi is 0. So z raised to 8 plus z bar raised to 8 is equal to 16 plus 16 is equal to 32. I can write 32 I0. So real part is positive, that is 32, imaginary part is 0. So this B is correct. Now next one. If Z1 and Z2 are two complex numbers such that Z1 plus Z2 modulus of Z1 plus Z2 is equal to modulus of Z1 plus modulus of Z2, then argument of Z1 minus argument of Z2 is equal to 0 minus pi by 2 pi. Now suppose Z1 is first complex number, we can write this as R1 cos theta 1 plus I sin theta 1 in polar form, and Z2 is second complex number, that is R2 in bracket cos theta 2 plus I sin theta. So modulus of Z1 is equal to R1 and modulus of Z2 is equal to R2. Z1 plus Z2 is equal to, if we add this, we will get R1 cos theta 1 plus R2 cos theta 2 plus I times R1 sin theta 1 plus R2 sin theta 2. So modulus of Z1 plus Z2 will be equal to, now R1 cos theta 1 plus R2 cos theta 2 square root of this, real part square plus imaginary part square and its square root. So I can write here R1 sin theta 1 plus R2 sin theta 2 square. So modulus of Z1 plus Z2 square is equal to, so it is R1 cos theta 1 plus R2 cos theta 2 bracket square plus R1 sin theta 1 plus R2 sin theta 2 bracket square. So we'll get here R1 square cos theta 1 square plus 2 times R1 R2 cos theta 1 cos theta 2 plus R2 square cos square theta 2 plus R1 square sin square theta 1 plus R2 square sin square theta 2 plus 2 times R1 R2 sin theta 1 sin theta 2. So here you will get R1 square cos square theta 1 plus R1 square sin square theta 1, that is R1 square, plus from this and this we will get R2 square plus now 2 times R1 R2 in bracket cos theta 1 cos theta 2 plus minus sin plus sin theta 1 sin theta 2. So this is equal to R1 square plus R2 square plus 2 times R1 R2 cos of, now this identity is cos of theta 1 minus theta 2. So this is modulus of z1 plus z2 square. And we have, what is our equation? Modulus of z1 plus modulus of z2 is equal to modulus of z1 plus modulus of z2. So if we square this, you will get modulus of z1 plus z2 square is equal to modulus of z1 square plus modulus of z2 square plus 2 times modulus of z1 into modulus of z2. Now we know modulus of z1 is r1, modulus of z2 is r2. So if we equate these two, so here we have here uh, this is modulus of z1 plus z2 square. So you will get r1 square plus r2 square plus 2 times r1 r2 cos of theta 1 minus theta 2 is equal to now z1 square, that is r1 square plus r2 square plus 2 times r1 r2. So if we compare these, so we'll get cos theta 1 minus theta 2 is equal to 1. So this gives you theta 1 minus theta 2 is equal to 0. So argument of z1 minus argument of z2 is equal to 0. So this first one is correct. This first one is correct. Now let us go to the next one. The smallest positive integer n for which 1 plus I upon 1 minus I bracket raised to n is equal to 1 is 8, 16, 12, be none of the above. Smallest positive integer. Now we have already seen 1 plus I upon 1 minus I is equal to I. So I raised to n is equal to 1. So we know I raised to 4, I square is minus 1. I cube is minus I. I raised to 4 is 1. I raised to 5 is I. I raised to 6 is minus I, and so on. So the lowest possible value of n is 4. So here 4 is not there. So we will take none of the above. Now next one. What is the value of log of minus 5? Now log of minus 5. So suppose we take z is equal to minus 5. So we can write this as minus 5 plus I0. So x is equal to minus 5, y is equal to 0. So we'll write r is equal to root of x square plus y square. So we'll get this as 5. And theta is equal to tan inverse y by x. So tan inverse 0. So here we'll get pi. It is pi. First value, that is pi. Theta is equal to pi. Now so here log z, we know it is log of modulus z plus I theta. So log z means I have taken here minus 5. Log of modulus of z means r. That is log 5 plus I pi. Now log 5, it is 1.6094 plus I pi. So this is log minus 5. So this first one is correct. First one is correct. Now next one. The value of product. Cos of 3 pi by 7 plus I sin 3 pi by 7 multiplied by, in bracket, cos 2 pi by 7 plus I sin 2 pi by 7 bracket square is 1 minus 1 I minus I. Now see here we have this cos theta plus I sin theta is equal to e raised to I theta. So this first term I can write e raised to I 3 pi by 7, and this second term as e raised to I 2 pi by 7. So e raised to I into 3 pi by 7 multiplied by e raised to I 2 pi by 7 and square of this. So this is equal to e raised to I 3 pi by 7 into e raised to I 4 pi by 7. And we know e raised to x into e raised to y, it is e raised to x plus y. So we get here e raised to I 3 pi by 7 plus 4 pi by 7. So this comes out to be e raised to I pi, 7 pi by 7. So it is cos pi plus I sin pi. Now cos pi is minus 1, sin pi is 0. So we will get minus 1 plus 0 I. So minus 1. So this second one is correct. Now let us go to next one. The cos alpha plus beta I can be written as, we have four equations given. Cos alpha plus beta I is cos alpha cos hyperbolic beta minus I sin alpha sin hyperbolic beta. Second one is cos alpha plus beta I is equal to cos alpha cos hyperbolic beta plus I sin alpha sin hyperbolic beta. Next one is cos alpha plus beta I is equal to cos alpha sin hyperbolic beta minus I sin alpha cos hyperbolic beta. And next one is cos alpha plus beta I is equal to sin alpha cos hyperbolic beta minus I cos alpha sin hyperbolic beta. So which one is correct? Now we have certain identities. We have sin hyperbolic I theta is equal to I sin theta. Similarly, sin hyperbolic theta is equal to minus I sin I theta, and cos I theta, it is cos hyperbolic theta, and sin I theta is equal to I times sin hyperbolic theta. These are some identities. Now cos alpha plus beta I, cos alpha plus beta I can write cos alpha into cos beta I minus sin alpha into sin beta I. So I can write cos alpha sin beta I, we know cos I theta is cos beta I, cos I theta is cos hyperbolic theta. So I can write cos hyperbolic beta and minus sin alpha. Now sin beta I. So sin I theta, it is I sin hyperbolic theta. So into I sin hyperbolic theta. So we get this as cos alpha cos hyperbolic beta minus I times sin alpha sin hyperbolic theta. Here beta. So if we check this, so we'll get first one is correct. So this is the correct one. This is the correct one. Now let us go to next one. The quadratic equation in Z whose roots are 8 plus 6i and 8 minus 6i. So how can we find quadratic equation? So first root is 8 plus 6i, second root is 8 minus 6i. So we will take here Z minus 8 plus 6i in bracket in second multiplied by Z minus 8 minus 6i, and this is equal to 0. Now if we solve this, Z into Z, Z square and so on, you will get this as Z square minus 16z plus 100 is equal to 0. So this last one is correct. Z square minus 16z plus 100 is equal to 0. So this is about multiple choice questions on complex numbers. So thanks very much. So if you like my lecture, I request you to subscribe my channel and also press like button. So thanks very much.